Hello everybody, Gadget Boy here. This will probably be the last video in the M8 Transistor Tester kit build series. Maybe. I might do another one afterwards demonstrating some of its functions. So we're just going to get right to it here. I've got my soldering iron started up here in the background. So we don't have a lot of components left to install. While these actually look like transistors, I was going to do a blurb on transistors, but most of these are actually not transistors. They're actually things I've never run into before. This one is something called a programmable reference. I'm going to have to do some research and learn a little bit about what that one does. This one here is something called a high regulator, which is something else I've never encountered, and I'll have to do a bit of research on as well. Now these are actually transistors. These two are, let's see, so the 9014. So those are the NPN transistors, and this is a PNP transistor. I'll get into the distinction between those two a little bit later. But very basically, the way a transistor works is you've got a pin where voltage comes in, and a pin where voltage goes out, and a pin where a reference voltage comes in. And depending on the type of transistor and the way they work, because there are a lot of different types of transistors, but the most basic way they work is you apply a reference voltage here, and the voltage that you've got applied here starts coming out here. It's basically a gate, and the third pin is the key. So the voltage is trying to come through here, you open the gate here, and it starts to flow. They get a lot more complicated than that, but that is the very basic idea of how you use a transistor. The other components we'll be mounting are this. This is it's an 8 megahertz oscillator. It basically, at its very basic, there's a little piece of quartz in here, and you apply a voltage across it, and that voltage starts to oscillate at 8 megahertz. And we'll get into stuff like that in other videos as I start exploring more advanced electronics. This is an LED. It's actually an LED that I pulled out of a thing that I showed you guys in a previous video, that elaborate spam mail. It came with a red one, this one's blue, so I want a blue LED on my board. This is how we'll get power to the board. It's a little 9-volt battery. This little guy, this is the brain. This is basically just a programmable chip. They've got their software on it. So there's that. This is the display, which is, from what I can see of the instructions, it's actually a little complicated to mount, so that'll be an interesting adventure there. This is a ZIF socket. Now I briefly mentioned what ZIF sockets were in a previous video, but ZIF stands for zero insertion force, and basically it means you can take a component like this capacitor here and stick it into the holes there, then you take this little lever and you pinch it down, and then it grasps whatever component you put in there. They're used for all manner of things. PIC programmers are one of the biggest ones. Any sort of memory chip that you have to put something on, it's very common. You drop your chip in there and you throw the lever down and program your chip. In this case, what they use it for is the components you'll be testing with this little tester. That's what you plug them into. And then this thing. I actually thought this thing was a variable resistor, but it's actually a switch. This just spins infinitely, and of course every time it clicks, one of these pins, I couldn't find a part number on it, so I couldn't find a data sheet, but a signal going into one of these pins gets pulsed out of the other pin whenever you turn it. and when you turn it in the other direction, I believe it will pulse off of another pin. And it also has a clicky button, so if you push down on the knob there, it also clicks. So that's kind of a neat little piece of hardware there. So I'm going to start with the transistors and transistor lookalikes here. Now, I'll do one live and then I'll do the rest via time-lapse, but these types of components tend to be very sensitive to heat. So it's a good idea to leave the leads as long as possible on these when mounting them, and try to limit as much as possible the amount of heat you're exposing the component to. So I know I'm going to be fighting with the screen a little bit on these, so I can't make them too long, but yeah, basically you want to just leave them a little ways away from the board so that you don't burn out the internals of the chip in there. So hopefully I will avoid damaging these with any heat. So well, you've already seen how I do my soldering, so we'll go into time-lapse here, and I'll be back in just a few minutes. Okay, and we're back. Well, sort of. I had a bit of a hiccup during that process. You might have noticed it if you were paying close attention to the time-lapse, where I accidentally soldered a component into the wrong hole. But I got that fixed. Now, we're going to do the rest of this live. Just to kind of show you through the more complicated parts of the process. So I'm going to, actually I probably could have done this part on the time lapse, but we'll just tack this thing on here real quick. Way off center. Okay, we're going to fix that. Bear with me a moment here. So the rest of the setup for this thing is actually a little more complicated than I thought. You can hear my cat Katie in the background there. She's complaining about something. I thought it was kind of just put the components on, make sure everything's plugged in correctly, and make it go kind of thing. But it turns out that's a little twisted. I hope that's okay. There are a couple of additional steps that you have to do, testing steps to make sure you have everything installed correctly. It seems like it's going to be a little interesting to do. Here we go. So we're just installing the switch now. Now you notice the switch has these great big clips there that are holding it into the board rather nicely while I work on it. You'll see those in a lot of electronic components. They don't serve any electrical purpose, except in some cases where you can maybe use them for some heat dissipation. But what they're actually used for is literally to just provide strain relief on the board. So actually, I'm going to spool out a bunch of solder here because this is a very hungry kind of joint. But yeah, you just pour on a ton of solder here. Oops. And it locks the component into the board securely. There we go, there's that. And then that is not going to go anywhere ever, because those are actually really hard to desolder once they're set. Next thing we'll do is the ZIF socket here. So we'll just seat that into the board. My little contortionism here to tack this on. Yeah, I figured as much. Let's get that centered. There we go. Just finish soldering this on, just like this. Actually starting to get a little excited because we get to attach power to this thing soon. And start doing some stuff. We're just going to finish tacking these on just like this. Alrighty, and that's on. Oh, we should get the LED in. LEDs are a polarized item here. Thankfully the board is marked with the positive side. The positive is always the longer LED, or the longer lead rather, on an LED. So just going to tack that on real quick. We'll come back around here to the other side of the board. Center it down. Alrighty, so the next step is power. Doesn't have any strain relief, so that's a little disappointing. We're going to come in from underneath on this one. Just like so. And negative lead. Do the same. I'll have to jury rig some strain relief with hot glue or 5-minute epoxy or something like that, because these joints aren't going to be very reliable. Cooperate you. There we go. So I'll have to. I'll do that off camera though. It's not important for the purposes here. Okay, so we're now actually at the part where we actually need to apply power. Now this runs off of a 9-volt battery. I have one right here. So we'll use that for our tests. But before I get started, I'm just going to quickly trim all of the excess nubbins here. Ow, that one lodged in my finger. That felt good. Oh, and that one went across the room. I'll just quickly turn these off. There we go. As I struggle to keep interesting commentary going, so sorry if you guys are bored. Things will get interesting again in a moment here. There's that. I should that should be okay. I'd like to trim those if I need to. Alrighty. So now the instructions say here, pardon me while I make some room here, to before you actually attach the brain or the display, you need to measure the voltage across pin 7 and pin 22, and that it should be 5 volts. If it's not 5 volts, you have done something wrong. So we're just going to set my multimeter to the voltage range here, and then we figure out which one is pin 7 and 22. So this is pin 1 here, so 1, 2, 3, 4, 5, 6, 7, and 1, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 15, 16, 17, 18, 19, 20, 21, 22. There we go. So now, with my, oh, I think I skipped one. Bugger. 1, 2. There we go. So now that I've got those in place, if I push this button, 5.13 volts. So it's a little high, but well within tolerances. So that means that we can move on to the next step. I'll just put my multimeter over here for the moment. And we'll disconnect the battery there. So the next step, I'm just grabbing the instructions over here to double and triple check what I'm doing to make sure everything is correct. The next step is to install the brain. It's this Atmega little CPU thing here. And we're going to very, very carefully insert this into the socket. Now, as usual, these pins are a little bit spread open. So I'm going to carefully, now there are actually tools for this, but if you're careful and you're grounded, that's what this metal tape here is on my table. It's a grounding strip. If you're careful, you can very gently bend the pins in yourself. Now, the CPU has a little marker here for pin 1. There's actually a divot in the ceramic coating and a little semicircle in the chip, and then you're going to line that up with the semicircle that's actually in the socket as well. So bear with me a moment. These can be a little challenging to get in, especially ones with this many pins. Come on, you. One of the biggest fears, of course, when plugging one of these in is accidentally folding a pin in underneath the chip rather than getting it into the socket. But it looks like I have succeeded. There we go. I didn't hear a horrible crunching noise or anything like that. Everything looks like it's seated properly. So now the brain is in. that's the thing that does all the stuff to make it work. Okay, so now the next step is to grab the display here, and it wants me to install these between pins 5 and 12, which are like that. Alright, so we're just gonna tack that on with a little bit of solder to kind of glue the pins on. And we're gonna singe my thumb a little bit. Wow, ouch. Okay. Now that that's seated, we'll just quickly weld these on, trying not to apply too much heat to the board here. Because we don't want to damage the display. Alright, so that's that. And that actually is all of the soldering we will need to be doing. So I will shut that off. Alright, so the next step here is to install these pegs, which support the display. And they are going to go here. And sorry, I know this is really exciting watching me struggle to put a screw into something. And here. This socket's getting in the way. Okay. Oops. Go over you. Alright. And then we are going to carefully seat this into its pins very gently and discover that I mounted the transistors a little too high on the board. Okay, so we're just going to very carefully lean these guys over. So they don't interfere with the display. Hey, you guys actually see what I'm doing? Certainly hope so. If not, I'll just do a couple of jump cuts on all this. Okay. Let's see. All right. We're gonna very carefully screw these in. I actually need a larger screwdriver. Just cheat and use the flathead side. Alright, and that is the device fully complete. Now, if all goes well, I should be able to plug this in press the power button here. Battery okay. Testing. No unknown or damaged part. Excellent, because I don't actually have something plugged in. Not calibrated. For calibration, clamp the 3 pins together and start with the key. Acknowledge the self-test with the key within 2 seconds. Disconnect. Okay. We're just going to turn this off. I think pressing and holding turns it off. Excellent. Alrighty. I'm going to go find some wire, and so we'll do a jump cut here while I go find some wire, and we'll do that self-test calibration power-up thing. Alright, so be right back. Alright, we're back again. So I have this little test lead. Now what it wants me to do is to short across the 3 different test pins. Now in this there are 7 holes, and the pin numbering is 111233. So we're going to bridge across all 3 pins, and I think the test lead wire that I chose, it helps if I have the ZIF socket open. There we go. If you open the ZIF socket, the wires go in a lot easier. Okay, so now we've got that shorted across, and we're going to need this. It's going to go through a little self-test with that those jumpers in there, and it's going to ask me to remove those and place this capacitor across pins 1 and 3. So we'll go through that whole thing in a moment here. So let's get this powered on. So push the button. Self-test mode, yes. Click. So it's gonna sit here and think for a while. Oh, I don't think I got it into test mode quickly enough. Okay, let's switch this off. We're going to turn it on one more time. We're going to click it a little faster here for self-test mode. So, self-test mode, yes. Isolate probes, okay. Now, at some point, it's going to ask for a greater than 100 nanofarad capacitor across those. Alrighty, so test end. Oh, yes, I'm sure it is. So let's put that capacitor back across. We're going to power it up. Testing. 214.8 nanofarad capacitor, and that is supposed to be a 224. So, it's reading a little bit low, but I may not have done that calibration quite correctly, so I'll mess around with a little bit more off camera. But as you can see, you put a component across it, and it tells you what it is. Let's try this resistor I have just laying here. See what it says about that. Let's see, that is gold, purple, or yellow, purple, gold, so 474 ohms is what that should be. Or 474 ohms. No, 47000. 470 k ohm? I'm pulling a blank here. Okay, 467 k ohm. So 470. That's right. I was still in the mindset of the 5 stripe resistors that we have here. Anyway, I'll go into some of the more advanced functions of this tester in another video. Thanks for sticking with me in my clumsy beginning to YouTube. If you enjoyed the video, do that thing that you do when you like videos, and I will see you next time. Thanks for watching. Bye.